Welcome to my first talk at Lenovo Connect. Today I will be talking about the current status of the 96-board Mezzanine ecosystem. My name is Tore Krug and I am an open hardware enthusiast. Next slide, please. Firstly, as I'm pretty sure that everybody knows about the 96-board Mezzanine, I wanted to firstly introduce it. You can imagine it like a Arduino shield or a Raspberry Pi head. But unlike the Arduino shield and the Raspberry Pi head, which use 5-volt logic level and 3.3-volt logic level, the 96-board Mezzanines use 1.8-volt logic level. This is due to the fact that 96-board is a platform for development, software development, hardware development on mobile system on chips. And the modern SoCs don't support these logic levels anymore. That's why we have these 1.8-volt logic level. It isn't as friendly to the normal beginner as the other two platforms. But you have the benefit that you are in a native system when you want to develop hardware for your mobile system on chip platform. Next slide, please. We have multiple available interfaces. We have a low-speed connector, which you can use for SPI. It has 2 I2C buses, intersound, 12 GPIOs, as well as reset and power. This means you can power your board from a mezzanine, or you can power your mezzanine from a board. If you have a very high power mezzanine, that means that it's preferred to power your board from the mezzanine. We have also a high-speed connector. That is a connector with a very fine pitch, which is again not very friendly for beginners, but it features more advanced interfaces like USB, MIPI DSI, SD, or SPI, MIPI CSI too. Next slide, please. 96-board mezzanines don't come in a predetermined form factor, unlike, for example, a Arduino shield or Raspberry Pi head. You can have them in the form you are required them to have if you have a specific application. For example, on the top left, we can see a gigabit Ethernet mezzanine with power over Ethernet that required more space, so it extends over the board space of a 96-board CE board and needs standoffs at the side. That is totally fine if your board requires it. We have also smaller boards, like on the right side at the bottom. That's the 96-board UART Mezzanine. It's very small because there isn't much space required. We also have mezzanines like the CQ96, which feature the form factor of a 96-board IoT board. So it would fit directly onto it and you can just screw it together. But the most used and most popular form factor for 96-board mezzanines is in the form factor of the CE Spec, like we can see with the sensor mezzanine on the top right. Next slide, please. Which comes with the benefit that we have the header support. We have low speed header support across all 96-board form factors, apart from the 3.3-volt spec, but that is not very much used. So essentially, you can create a mezzanine that uses the low-speed header, and you will have support across 99% of all 96 boards. You will have support for the consumer edition extended, IoT extended, as well as enterprise edition, and the system on module edition. There is a carrier board which has support for it as well. You will have support for the high-speed header on the consumer edition extended, as well as on the system on module carrier. You don't have support for the high-speed header on the enterprise edition, as those high-speed interfaces are available through other more common interfaces, like connectors. it's essentially more like a PC-like board. For example, you have PCIe, thus you don't really need to have the high-speed connector. Next slide, please. Another benefit of using the 96-board CE form factor is also the stackability. So you can have, for example, you want to develop a product that requires a specific sensor and still want to have 4G LTE connectivity. And you can have a LTE mezzanine and a sensor mezzanine stacked on top and develop with that. If you are ready with it, then you can create your own custom PCB. But that's a benefit that you can stack PCBs on top. I demonstrated it here with 4 mezzanines, 3 CE mezzanines, and a small UART mezzanine on top. Next slide, please. There are currently a bunch of commercially available mezzanines, for example, from Shira Tech, but also other companies. There are camera mezzanines, security mezzanines, for example, a trusted platform, connectivity mezzanines, as I mentioned, 4G, LTE, NB-IoT. In the future, maybe lower. We have mezzanines for makers. That includes the sensor mezzanine, as that one has the growth connector, which is an ecosystem from Seed Studio to get relatively quick started with sensors and actuators, as well as the Arduino connector. So that is more maker-friendly, as it adopts the 96-board form factor and connectivity to those platforms. For more advanced users, we have the FPGA mezzanine, so we can develop your own custom solutions like accelerated detection of objects inside of those. If you're interested in viewing more of those products, I added QR codes throughout these slides. So if you're interested, you can just scan it with your phone and you will be like landing directly on that webpage without tapering the long URLs. Next slide, please. There are community member mezzanines. The Proto Mezzanine was designed by Sahar Sarup, and the GPS Mezzanine and the CE form factor, as well as the Robo Mezzanine, were designed by Michael Welling. Those are currently, unfortunately, not available for purchase. Those do exist as designed. They are open hardware, and in theory you can build them yourself. But apart from that, there isn't currently much going on with the community member mezzanine initiative, and that is something we really want to work on to get more people involved into it, to have a more open community to create even more mezzanines for it. Next slide, please. I myself started to work on mezzanines, a smaller growth mezzanine, a GPS mezzanine, in a low-cost version in the IoT form factor, as well as a Crypto Mezzanine, which is basically a breakout board for the for a trusted platform chip from Microchip. So we can experiment with that. It's easy to just add it onto a IoT board. I have it here myself. It's been built by Oshpark, and on the back I have a Orange Pi i96, which is one of the few IoT boards that are capable of running Linux, where you can also see the difference between a CE board size and a IoT board size. Next slide, please. I've been also especially working on a UART Mezzanine to replace the old UART Mezzanine that was designed back in 2015, as those aren't very available anymore and needed an upgrade anyway. So I've been building a open source board in KiCad, as you can see the rendering on the right. It will be a drop-in replacement, so you can just stack it and you don't really have to change anything. It will be CI compatible, features USB Type-C, unlike the micro USB on the old UART Mezzanine, and will also feature a 2.54 or 0.1 inch breakout for GPIOs, I2C, and voltage rails to make it more friendly to get started with some very basic sensors. I designed it and it's currently not built yet, but I got the components just before the talk today, so you can probably follow me on Twitter and see that I'm going to build that, and hopefully it will be available soon. Next slide, please. All of those projects use templates I and other persons have created in the Mezzanine initiative. Those are open source templates you can get from GitHub. They are licensed under BSD, and there are different templates available for different CAD programs. KiCad and Eagle have both support for a consumer edition template as well as a IoT edition template. Altium and GEDA only have the consumer edition available. If you are not too much into designing your own board, if you're not feel comfortable with it, there's also the possibility to use Geppetto from Gumsticks. It's basically a web-based drag and drop builder for boards, and those support 96Boards mezzanines as well. Next slide, please. Another possibility when you have ideas, just to reach out to us, as we have a bi-weekly Zoom call. We have the GitHub repository, so if you have an idea and think it's great, you can create a issue and start a discussion about your idea about your mezzanine, and somebody might pick it up, create it, make it into the reality. There's also the 96Boards forum and the 96Board Discord. On all those platforms, I am myself, so if you have any questions, you can ask me there. Next slide, please. 2 days ago, the 96Board CE Spec version 2 was introduced. It features a new high-speed connector, high-speed header 2, which will feature 2 CSI 2 to 4 lanes, 2 lanes of PCIe, as well as USB 3.0 shared across the high-speed header 1 and high-speed header 2, and CAN bus and analog audio on the new low-speed header. Those are optional, but they give you more flexibility if you want to design a product, a mezzanine. The mezzanine specification on the website wasn't updated yet, which is something I hope 96Board will do in the future to accommodate the new spec, and also give recommendations on the selection of connectors like they did with the version 1 spec. Next slide, please. And that is, and I hope you liked it, and thank you for watching. I hope we can answer here some questions. Bruno Verachten. I saw a few people unhappy with the latest 96Board specification. Do you mean the specification itself for the board or for the mezzanines? Because currently there's only the specification for the boards, and that doesn't change much with the mezzanines. So if it's like something software related, like specifications boards have to follow. That's more on the board side rather than the mezzanine side. What about also from Bruno Werchten, what about a HDMI in mezzanine? That is possible. I hope somebody would pick that up. You can always go over to GitHub and create your own issue, and then see if people are interested and build something like that. Any more questions?
There is a question in the chat. What's the implication for the mezzanines? From Bruno.
A new one?
Yes.
Could you please repeat that? I'm not able to see that.
Okay. I believe Bruno was following up on his truncated question around people being unhappy on the 96Boards specification.
Mm-hmm.
He wanted to know if there was any implications for the mezzanine side.
I think the only change really is that previously you had your UART 0 for the bug over the low speed header, but some manufacturers created their own 3.3 volt header on a non-specified place, and I dealt with that as well. So those manufacturers created their own header, which was so high that I was not able to add mezzanines on top of the board. And with the new Spec V2, it's necessary to have your debug UART over USB to UART adapter on board, so you plug in your USB cable. And that will hopefully end the pain with cutting down your UART header just because you want to add your mezzanine on top.
There is also a question that may be relevant in the Q&A about supporting ACPI on any of the mezzanines.
I'm not aware of that. I think that is a question more regarding people from 96Boards directly.
I think you're right. Let me check the chat and see if there's any other questions. Wait, I see. There's one question about that I haven't seen. There's many mezzanines that are not available on the market now. Do you have any plans to remake those? There is the UART Mezzanine, which is out of stock for a long time, and I know you just mentioned that.
Yes, I will remake that. It will be completely compatible, and there's also some talks about a UART mezzanine with a pass-through, so you can have it will be essentially be in a CE form factor, and you can stack your other mezzanines on top. So it would be a mezzanine you just leave on your board, and if you want to have another mezzanine, you stack it on top. Now it's basically that you have your UART mezzanine, and it goes on top of every other mezzanine. And if, for example, you have a mezzanine like the FPGA one, which doesn't have the low speed header anymore, this here is not the low speed header, that's a custom header, then you were basically screwed. So I am planning on building such a mezzanine as well, to just have your UART and pass through all the other signals. Apart from that, sorry.
Go ahead.
Apart from that, all my designs will be open source, so if somebody's interested, they can just manufacture them basically yourself. You can upload it to a PCBA company, and just buy like hundreds of them. So it will be completely open source, using open source tool to make it as accessible as possible to everyone. There was a question.
I think we've hit all the questions in the chat.
Okay.
Plus, many kudos for you on a well done session.
I can't see them.
You'll have to watch the video when it comes through. Okay, we'll give it another few 30 seconds or so for any additional questions before we end the session.
Yeah, I mean, I can talk about something else personally. The specification, the Mezzanine specification, talks about a EEPROM for automatic detection of boards, and then like loading kernel modules, device tree. But that was never really implemented, unfortunately, which is really a bummer. But that's more down due to the fact that people couldn't decide where it should be implemented in U-boot or like kernel/user space. And yeah, sadly, that's not a thing. And I would like to see that, but no. Somebody reinvents the wheel every few years, and then nobody really uses it in a large capacity. No further questions?
I don't. More kudos. No additional questions. Since we have a few minutes, can you explain? I think earlier in the slides you talked about things being CI ready. What does that mean?
Oh, so the UART Mezzanine comes with a user space program for a host system, so you can remotely reboot or power off your 96 boards, and that is specific to the UART IC on the Mezzanine. And I essentially took that same IC to keep the functionality with the CI. So you would just use the new Mezzanine, plug it in over a Type-C cable, and it would work with the old CI. So you can still remotely reboot, reset without changing the software.
Thank you.
No problem.
And I want to give another 10-20 seconds to see if there are any additional questions in the chat. Otherwise, we'll wrap up.
Sure. Yeah. the chat is quite. Is it? Oh, I was on Q&A chat. Public. I will have to see it somewhere else.
Yep. Yeah, that's a little confusing. Okay, so we'll wrap up the session now. Thank you very much, Thor. And
thank you for your time. Thank you for the opportunity to speak here. And I hope everybody stays positive and healthy, but COVID-19 negative.